Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
This scene is brought to you by the Gauteng Department of Education. So today we're going to be looking at the value of the pH. We're going to be looking at the pH value and specifically at the concept of the pH value. And also this topic is found under the strand matter and materials for your term 2. Right, let's proceed. Lesson objectives. This is what we need to achieve by the end of this lesson. So by the end of this lesson, you should know how to compare and contrast acids and bases. So by the end of this lesson, you should be able to compare and contrast acids and bases. So you still remember on our previous lesson, we talked about acids and bases, right? So today we're going to compare and contrast between the two. We are also going to define and analyze the pH scale. And we need to be able to know why is pH measurement so necessary, right? So we need to define and analyze the pH scale and also tell us why pH measurement is necessary. We also need to be able to test universal indicator, test using universal indicator for more household substances for the degree of acidity or alkalinity. Are we together? So we just talked about acidity and alkalinity in the previous lesson. So for today, we're going to look at their degrees of being basic or being acidic. Moving on. This all is found on the CAPS document on page 67. Right, pre-knowledge. This is what we have done in previous grades, right? And also the same grade. So we use such information as our foundation to build up on today's topic. So in grade 7, we have done the introduction to the periodic table of elements. If you still remember, we showed you a periodic table looking something like this, right? It has all the known elements that are discovered so far, right? And still remember that we said that there is still room for discovery. So these are all the known elements so far, which are 118 in total. We also have done acids and bases and also neutrals in grade 7, right? We have done acids and bases and also talked about neutral substances. Still remember a picture like this when we were talking about a pH scale, which is a scale that ranges from 0 to 14. We also have talked about atoms in grade 8, right? We said an atom is made up of subatomic particles, which are your protons, your neutrons, and electrons. We said an atom looks something like this, and it is a building block of matter. You still remember such? We also talked about compounds and chemical reactions in the same grade, which is grade 9, right? And we've showed you elements and compounds, right? For example, for compounds, we have H2O, which is a molecule of water. We also have talked about acids and bases. Now let's move on. Baseline activity. So for this baseline activity, I am going to give you 5 minutes to complete this activity, right? But firstly, let's go through the questions. It says classify each of the following as an acid or a base. So you need to just classify it as an acid or a base, right? We have description and we have the column for acid or a base. Let's go through the description first. It feels soapy and smooth. It can neutralize an acid. It is found in green plums and grapes. It tastes bitter. Handy, caustic soda, physical drinks, gastric juices, pH of 9 and pH of 1. Now let's meet again after 5 minutes. Welcome back, grade 9s. I hope you have enjoyed the baseline activity, right? Now I see we have been getting some answers, right? For those who are not aware of the WhatsApp number, it is 082 760 2630. Send us your responses or questions if you have, right? Now let's look at the solutions. So you needed to just classify each of the following as an acid or a base, right? So now it feels soapy. That is a base. Don't forget to mark your work now. You give yourself a tick. It can neutralize an acid. It also is a base, right? Found in green plums and grapes. What is that? It is an acid. Are we together? Now tastes bitter. What's that? It is a base. Handy Andy. What's that? It is a base. Caustic soda. That is an acid. Physical drinks. Those are your acids as well. Gastric juices. Those are acids as well. pH of 9. That is a base. And pH of 1. That is an acid. Now I hope we have got correct answers and have written corrections. If not, right? So now let's proceed. Terminology. Terminology is so important so that you can be able to understand the concepts of the topic. So let's look at the terms that we have then. We have acids, right? We said acids are substances with a pH between 0 and 7. Now mind you, between 0 and 7, right? Right there in between. Also, bases are substances with a pH between 7 and 14. It doesn't say from 7 to 14, but between 7 and 14. Also, alkali. Alkali is a base that can dissolve in water. We also have pH value. So it's important to grasp this one because it is the topic for today as well, right? pH value is the number between 0 and 14 that tells us how acidic or basic a soluble substance is, right? It is a number between 0 and 14 and it tells us how acidic or basic a substance is. We also have neutral. Neutral is a substance that is not an acid or a base. So it is neither acidic or alkaline, right? And it has a pH of 7. We also have indicator. We said indicator is a dye that has different colors in acids and bases. So this particular dye, when it reacts with an acid, it gives off a different color. And when it reacts with a base, it gives off what? A different color as well. Now let's proceed. So what is pH value? What is this pH value that you are talking about? So we said pH value is a number between 0 and 14 and of which it tells us how acidic or basic something is, right? So we said that it is a number between 0 and 14 and it gives us a range of how acidic or basic something is. So for pH value, we use indicators so that you can be able to check how acidic or basic a substance is. For instance, here, I have some indicators here, right, of which we used in the previous lesson. Litmus paper, right? So this is a color code for litmus paper. It ranges from 0 to 14 as well. So as you can see here, there's color ranges, right? That pink, almost orange, orange to yellow, green, blue, purple, and so on, right? Those ranges of colors are the ones that tell us how acidic or basic something is. We can also use a pH meter to test for acidity or alkalinity, right? So don't be confused when I say alkalinity. Alkalinity is another word for saying something is basic or it is a base, right? So now we can use a pH meter to test for acidity or alkalinity, as you can see on our demonstration here, that you can put this meter inside the solution and to tell you the range in which it is acidic or basic. Moving on. So now, some of our foods make our tongue curl up because they are sour. So now, from this statement and the following statement, I want you to ask yourself a question as to why are they sour, or why are they bitter if they are bitter, right? So now, some of our favorite foods make our tongue curl up. I think you relate somehow, right? They make your tongue curl up, like lemons. This is because lemons are sour. Not only lemons, we have also pickles, which are also sour in taste. But now, why are they sour? Let's look at the following statement. The following statement says, some foods have a bite of their own because they are somewhat bitter. Right? Some are sour, some are bitter. Look at this, right? Here's an example of someone tasting some bitter food. Look at this. It is not it is not a pleasant what? Taste. It is bitter. So some foods are sour, some are bitter, some are sweetish or salty. But now the question is, why? Why are they bitter or sour? But no, don't stress, right? Because there is a reason for this. The reason behind that is because they are either acidic or basic. So meaning these substances can be acidic or bases. Like the example we have showed you there, right? Of lemons. Lemons, we said they are sour. They are sour because they are what? They are acids. And the bitter substances, they are bitter because they are bases. So now, some foods, these foods are either acidic or basic. But it's not only food that we say it's basic or acid, right? There are other substances besides foods that have these characteristics. So substances like soil, like water, and so on, right? They can either be acidic or basic, and we're going to look more into that. Now, chemicals may be classed as acids or bases, which I've mentioned just now, right? Substances such as food and other soil and so on can either be acids or bases. So we classify them according to how they range on the pH scale, whether they are acidic or basic. So we also have substances that are not acidic or basic, and we say such substances are neutral. So if a substance is not a base and it is not an acid, we say it is a neutral substance. And we use what? We use a pH scale to check for acidity or alkalinity. So as you see there, it says pH measures how acidic or basic a solution is. So now, let us remind ourselves of some properties of acids, right? The characteristics of acids. We said acids are often tasting sour. They are sour in taste, right? They make our tongue curl up. And also, we have strong acids and weak acids. This is the pH value and the range that I'm talking about now, right? So now, strong acids can burn your skin and eyes. But there are some acids which are consumables, which we can say these are weak acids. So strong acids can burn your skin and eyes, and also strong acids can dissolve metals. Now here are some examples of acids. Lemon juice, for example, it is an acid. It is sour in taste, right? Vinegar, it is an acid and it is also sour in taste. Now carbonated acid, that one, it is sour, but remember it is not a consumable. Hence we say it is very dangerous, right? It is dangerous. It is the one that can burn your skin and eyes as well. And often you see signs like this. These signs are for showing you that this product is consisting of acids or it is acidic. Now, properties of bases. We're still reminding each other of these properties, right? So bases, we say that they can taste bitter, sweetish, and somehow salty, right? We can be able to consume some of the bases as well. But we also have strong bases that are not consumable. Those are the ones that can burn your skin and eyes as well. So now bases react more easily with protein than with metal, and they are often used for cleaning. So now we're talking about bases that are in your home, like your cleaning detergents, your handy and so on. Here are some examples of bases. We have baking soda, soap, and drain cleaner. So this one, if it comes in contact with your skin, it can harm your skin, right? It is dangerous as well. And here are some examples of bases, right? Your thick bleach, your ammonium hydroxide, and soaps, and so on. Now, neutral substances. We said neutral substances are not acidic or basic. For example, pure water, right? Pure water is right there at pH 7, in between, right? It is not acidic and not basic. So therefore we say it is neutral. So now let's talk more about other substances. So now, more substances can be identified as either basic or acidic. For instance, the soil in the backyards of our homes, right? So that soil in the backyards of our homes can either be acidic or basic. Now, which soil am I talking about? I'm talking about this whole land here, right? This whole soil, here, right? It can either be acidic or basic. What do I mean by that? Let's look at this picture here, right? These are two types of soil, right? We have the loose soil, which is well drained, and we have clay soil, which is alkaline, and the loose soil, it is acidic. These soil types are different in terms of their pH value. This one is acidic and this one is alkaline. These soils serve different purposes as well. The other one can be able to plant vegetables, and other one can be able to plant other different plants and vegetables as well, right? Depending on the acidity and basicness that we need for a certain plant. But that is a story for another day, right? For now, let's just focus on that the soil can either be acidic or basic. Let's not lose that concept. Right. pH. So pH is a special name which is given to the acid or base characteristic that a substance has. But now my question is, what is this pH? We have been hearing pH this, pH that, right? What is a pH, or what does pH mean? Besides being a special name given to the acid or base characteristic that a substance has. So now, let's break this. Let's break this pH into two. P stands for potential, right? And H stands for hydrogen. Now, why do I say that? Remember, we said acids are what? Are substances which have excess of hydrogen ions, right? So now P stands for potential and H stands for hydrogen. So it means that hence the potential of a substance to attract hydrogen ions. The more the hydrogen ions, the more the acidic the solution is. Moving on now, how do we measure pH? We can measure pH by using special strips of paper called pH paper, which we used last time, and it is called litmus paper. So just to remind you, right? Still remember on our last topic, we did experiments, right? Or an experiment. We used blue litmus paper, which turned red if the solution is acidic, and we used red litmus paper, which turned blue if the solution is basic. You still remember that? So not only that, we have other universal indicators, right? And I'm going to use one for you today so that you can be able to see how it is used. So now, how does it work? How does using the litmus paper work? First of all, the paper is treated with chemicals that change color to show the pH, right? As you can remember that blue litmus paper turns red if it's acidic, red litmus paper turns blue if it is a base, right? So it is treated with chemicals that change color to show the pH. Also, when the paper touches the substance being tested, it turns a specific color to tell if the substance is an acid or a base, and of which I've mentioned here, right? So this is how we dip in that paper into our solution to check for the color change and decide whether it's an acid or base, depending on that color that we see there, right? So now, universal indicator paper on the pH scale. So this is how you see a universal indicator paper, the green one there, right? It is green in color, and it will give you a range of colors depending on whether it is more acidic or more basic, right? It gives you a range of colors depending on the ranges of alkalinity and acidity. So if it is green like this, going to that side of acids, right? The stronger the acid gets, the more you see these colors like red, orange, yellow, and if it is weak, the more you see the greenish colors, right? But going to the side of alkalines, it's the more you see the blue and to almost violet, right? Or purple, to tell us that the strength is increasing in terms of alkalinity and acidity. So now let's look at some of the strongest acids, or some of the strong acids. Strong acids are found in the range of 1 and 0, right? To indicate that they are very strong. You see these colors here, this orange and red. And also to indicate that it is a strong base. You see this color which is somehow violet or purple, right? This means what? It is a strong base. Also, for weak acids, you see the color ranges between green, right? And for weak bases, that's where you see your blue colors. Now let's look at some examples of strong acids, strong bases, weak acids, and weak bases. So for your strong acids, you have your stomach acid, which is known as the hydrochloric acid. And for your strong bases, you have your cleaning detergents, right? Like your sodium hydroxide and so on, right? You also have weak acids, and example of that is tea. And for your weak bases, you have eggs, right? So meaning if you were to test for these substances, these are the colors that you would get for each of the substances there. Right. Remember that a universal indicator has the ability to indicate the full range of values on the pH scale by change of colors. So now let's take a minute break. We'll come back after a minute. Welcome back, grade 9s. So now I hope you understand the ranges of colors that I'm talking about, right? From having a universal indicator being green, going all the way to acids having that change of colors, having all those bright colors indicating what? Acidity. And having all the dark colors on the other side indicating what? Alkalinity. So let's move on with our lesson. The pH scale. So we said a pH scale is a scale that ranges from 0 to 14, right? And not only that, pH 7 is neutral, which means it is neither acidic or basic. So now from this range from 0 to 14, 7 is the center and is where you find neutral substances. So between 0 and 7 it's where you find acids, and between 7 and 14 is where you find bases, right? So I gave you an example here, right? To say that pure water is pH 7, which means it is neutral. So low pH, that indicates acids, it is 0 to 6.9. So now notice there, between 0 to 7. So it is 0 to 6.9, and it is where you find acids. By the minute it says 7, it is neutral. So from 7.1 to 14 we get bases. And also closer to the ends of the scale, that's where you find the strongest solutions. So closer to the end of the scale, the stronger the solution becomes. So if you get 0, that is your strongest acid. If you get 14, that means it is your strongest base. Moving on. So I'm going to show you a table here, right? And this table shows the colors that indicate the pH of a solution after adding a universal indicator. And this further helps us to use the colors to identify the pH value to describe whether the acid or base is strong or weak. So here, green, as you can see here, along green, the pH range there for green, it is 7. That's where you find your neutral substance, right? And your universal indicator would be green if you use a paper, right? So now for weak acids, remember acids is between 0 to 7. So meaning it is any number below 7, right? So now you start finding what? Orange and yellow, indicating your weak acids. So they range from 3 to 6. Then from 3 going down to 0, that's where you find your strongest acids with the color red. Moving on, from the universal indicator again, going above 7. On pH 8 to 11, you find weak bases with the color blue. Then from 11 going all the way to 14, you find your strong bases which have the color indigo or violet. Right. We said an acid is any substance with a pH value of less than 7, and it is considered an acid for that, right? And we have a pH scale here again. So on this pH scale, look at the coding there, right? From 0, we have all the red there, right? That's if we use those blue and red litmus paper, right? We have all the red here, indicating what? Acids. So it means that it's any number between 0 and 7. And a red solution after adding few drops of universal indicator indicates a strong acid with a pH value of less than 3. So orange or yellow solution after adding a few drops of universal indicator turns what? Orange yellow color, right? Which indicates a weak acid. So now moving on. For bases, we said a base is any substance which has the pH value greater than 7, right? And therefore we say it is a base. Here is another pH scale here, right? Notice the color change now. I've put blue on this side, right? Indicating what? Bases. So now a blue solution after adding a few drops of indicator indicates what? A weak base. Then when you get indigo to almost purple and so on, it indicates what? A strong base. And it ranges from 11 going upwards. Now pH 7. pH 7, we said that these substances are neither acidic or basic. So therefore we say they are neutral. They are neutral substances, right? Right there in between, we find neutral substances. So now you notice that there is no color change after a few drops of universal indicator, and the solution has a pH of 7. So now, how to use the pH paper? How can we use a pH paper to test for acidity and alkalinity? We place the edge of the paper into the mixture, right? You place the edge of the pH paper into the mixture. Secondly, you observe the color change of the pH paper. Thirdly, you match the results to the colors listed on the pH scale. And also, the colors that match with a correlated pH number tells you the range of the pH value, or whether it is acidic or basic. Then the number is the pH value of the sample. So now, if the pH number is less than 7, we say it is acidic. So I'll keep on emphasizing this there, right? So it dwells in your minds. We said that if the pH number is less than 7, it means that the substance is acidic. And if it is more than 7, it means the substance is basic. As you can see here, right? From 7, you have neutral substances. Going all the way above 7, those are your bases. They are alkaline. From 7 going down to 0, that's where you find your acids, meaning they are acidic. So now let's move on. So why is pH important? We've been talking about the level of acidity, level of alkalinity. Why is this important? Now let's give a few examples here. The first one here, fish cannot live in the pH, or if the pH is too high or too low. So meaning they require minimum amounts of pH, or an average amount of pH, which is neither too low or too high. So if you can see that fish die here around this pH, right? Because it is too acidic for them. So they require average amounts of pH to survive. Also, soil has to be in a certain pH range for plants to grow and stay healthy, right? So that one differs with the types of plants as well. There are plants that love acidity and there are plants that depend on alkalinity, right? So now, as you can see here, this is the range that is almost perfect for their acidity, right? It does not need to be too much acidic as well, or too basic. Are we together? So now, investigation. So now we're going to investigate household substances to test whether they are strong, weak acids, or weak bases, or strong bases, or they are neutrals. So we're going to take a break for 3 minutes, then we're going to engage in our activity. After 3 minutes, we'll meet again. Welcome back, grade 9s. Now I hope you are ready to engage on our investigation, right? Remember, we are investigating household substances to test whether they are strong or weak acids, whether they are strong or weak bases, or whether they are neutral. So now I hope you are ready for the experiment, because you can see that I'm ready, right? I'm wearing my lab coat and safety gloves, right? Don't forget your safety measures for the lab. Right. Now let's look at the aim of the experiment. The aim of the experiment is to test how household substances for their degrees of acidity and alkalinity, whether they are strong or weak bases or acids, right? Also, the hypothesis for this experiment is that in the presence of a universal indicator, strong acids turn red, weak acids turn orange-yellow, strong bases turn violet, and weak bases turn blue. Then as for neutral substances, they have no what? They have no color change. And we have our apparatus just right in front of us, right? For our apparatus, we need a universal indicator. So now, I think we are wondering, what is this, right? This is red cabbage, right? This is red cabbage. We have put our boiled red cabbage so that we can be able to use it as a universal indicator. So we have glass beakers, here they are in front of us, and we have household products, which are your lemon juice, your tartaric acid, bicarbonate of soda, water, and also soap, right? We're going to test these, right, for their acidity and alkalinity. Let's look at the method. So for method, we have to pour different household substances into the glass beakers, of which I have done now, right, for time's sake. We have to label the beakers accordingly, right? As you can see, they are labeled here: tartaric acid, bicarbonate of soda, and so on, right? Then we need to pour a few drops of universal indicator in each glass beaker. So we're going to pour this in each glass beaker to see the color change, right? We're going to observe the changes and record the results. So now let's get on to our experiment. So now we have baking soda, right? Which is this one, right? We have baking soda. So we're going to pour a universal indicator that will tell us or give us a range of color to tell us whether it is acidic or basic, right? Baking soda. Now let's pour our universal indicator and observe the changes. Right? Can we see this color? Observe this color carefully, right? And think of your pH scale. What is the color? And it will tell you whether it's a base or an acid. Then we have what? Shampoo. We're going to pour a universal indicator again on the shampoo, and it will tell us whether it's an acid or a base. Look at that color, right? Look at that color. Can we see? Now let's take our tartaric acid. Let's check for the color change again. Wow, this is magic, né? Observe the color change as well. Now let's take lemon juice. Let's pour our indicator. Let's observe the changes. And finally, let's take water and pour our indicator to observe the changes. Right. So now, let's conclude this, right? Let's conclude this. We're going to conclude this by putting them in order of their acidity and basicness, right? So we're going to use the results to sequence the substances according to the most acidic to most basic. So now, look at this. The indicator did not change color, right? The indicator's color is still the same. So we're going to put it in the middle, and that is our water, right? I'm going to put it in the middle. Let's go to our acids. Looking at these two acids, vinegar and tartaric acid, right? Which one is more brighter and which one is darker, right? The lemon juice, it is quite lighter, right? So we're going to put it here. So it means what? It is a weak acid. So looking at tartaric acid, it is a bit darker. So it is a strong acid. So now between the two bases here, which one has a stronger color, right? We have our bicarbonate of soda here, as you can see. So we're going to place it here because it is blue, indicating what? A weak base. This one is violet, right? So it is a strong base. So our shampoo is a strong base. So they range from 7 all the way to 0 and 14. Can you see that? 7 being the most neutral. This one is a weak base, weak acid. This one is a strong acid. This one is a weak base, and this one is a strong base. So now let's take a minute so that we can go back to our lesson. Now, welcome back, grade 9s. I hope you have enjoyed our lovely experiment, right? Don't forget to send us your WhatsApp questions or answers to 082 760 2630. Now, let's move on. Before we move on, we have an activity here, right? This activity, you just need to study the graph and answer the questions that follow, right? So, here are the questions for the activity. You need to tell us what type of graph is this. Is the heading of the graph relevant? And you tell us why. Which substances are acid? And you give a reason for your answer. Which substances are basic? And you give a reason for your answer. Also, are the substances you identified in question 1.4 weak or strong bases? Then you give a reason for your answer. Then lastly, which substance is neutral? Then you tell us the reason for your answer. So now I'm going to give you 4 minutes to complete this activity. Welcome back, grade 9s. I hope you are still enjoying our activities, right? Remember, activities are a way of testing our knowledge, right? So you don't need to get tired when writing activities. So now let's look at the solutions. So now, number 1, what type of graph is this? It is a bar graph, right? It is a bar graph. 1.2, is the heading of the graph relevant? And why do you say so if you say it's relevant? And the answer is yes, it is relevant because it shows different household substances with their pH levels. 1.3, which substances are acids, and give reasons for your answer. The substances which are acids, it's your lemon juice and vinegar. Now, why do we say so? It is because they show what? A different color when tested on the indicator, right? Which is pink or red. Also, which substances are basic? Give a reason for your answer. It is baking soda, mouthwash, shampoo, and antacids tablets. This is because their pH values range from between 7 and 14. 1.5, are substances you identified in question 1.4 weak or strong bases, and give reasons for your answer. They are your weak bases because some are consumables and shampoo, and if shampoo comes into contact with your skin, they are weak bases and some are consumables and shampoo comes into contact with your skin. Therefore, we don't say it is a consumable. 1.6, which substance is neutral? Give reasons for your answer. It is water because there is no color change on the indicator. Right, now let's summarize today's lesson. So today we talked about the fact that pH comes from potential hydrogen, or it stands for potential hydrogen, and it is a special name given to the acid or base characteristic that a substance has, right? And also we measure pH by using litmus paper and universal indicators to indicate the full range of values on the pH scale by color changes. We also talked about how to use litmus paper, right? We said you place the edge of the pH paper into the mixture. Secondly, you observe the color change of the pH paper. Then you match the results to the colors listed on the outside of the pH paper package. Then the colors that match with a correlated pH number will tell you the pH range, right? And also the number is the pH value of the sample. So I hope you have enjoyed today's lesson. Let's meet again when we're talking about reactions of acids and bases under neutralization and pH. So we're going to react the two, right? So now, thank you and goodbye.